Hello, in this video we're going to be looking at molar mass, and molar mass is represented by the symbol M. It's just a capital M. Now, molar mass, the meaning of molar mass is mass per mole. Meaning of molar mass is mass per mole. Mass per unit mole. Mass per unit mole of substance. So basically what this means is that this represents the mass that, let's say you had 1 mole of the substance, then this number would represent for a specific molecule the mass per unit substance, the mass that 1 mole of that substance would have. So if this was 2 moles, then there would be double of whatever the molar mass was. And because of this definition, mass per unit mole, we represent the units of molar mass as now we represent mass in grams. So we have grams here. Let's say these are the units, which would be mass. And because it's per unit mole, per indicates that we have to divide this here by this here. So we divide that by the moles. Mole. That's per the moles. This is the units. This is the what it is, mass. So because of this and indices rules, we can represent this as grams multiplied by 1 over mole. 1 over the unit mole. And this can be better represented as, let me make this bigger. This can be better represented as moles to the power of -1, so grams per mole. And this here to the power of -1 basically means that it's 1 over moles to the power of -1. So 1 over mole to the power of -1. I mean 1 over mole to the power of 1. But because anything to the power of 1 is itself, we just ignore that. It's just 1 over mole, but it's this. Grams per mole. Okay, so how is this useful? This is useful for linking mass and moles in a given problem or equation. And an equation which we can represent this as, based on what I've explained so far, is molar mass equals mass over moles. So I can also represent this as mass equals molar mass times moles. So let's say I wanted to find out the mass, I could multiply both sides by the number of moles and get the mass. And here, through doing that here, we'd get the mass. And we could also rearrange this to put moles on one side. And the way we would do this is multiply both sides by moles. But multiply both sides on this equation by the number of moles, so we'd get number of moles over here. And then what we would do is divide both sides by the molar mass. So what that would do is we'd have moles over here, so moles over here on its own. And because we're dividing both sides by molar mass, it would disappear from here, but it would appear on this side. So it'd be equals mass divided by molar mass. And therefore we have now 3 equations for working out whatever unknown we have when we're using the 3 variables moles, mass, and molar mass. You don't need to remember these. If you understand the concept behind it, it's quite easy to derive these equations. I'd say this one is remembering the definition of this molar mass can help you to link these, and then you can form this equation and solve any, like, create any of these other equations from that. And well, let me just get rid of all of this stuff. So far we've covered that the units of molar mass are grams per mole, and it's found by dividing the mass in grams by the molar mass, by the moles, by the number of moles in moles. Well, no, sorry, wrong way around. By dividing the number of moles in mole. Now, using this information now, and this concept, what we're going to do now is look at a problem, and I'm going to work through it. Okay, I have my calculator ready. Calcium carbonate has the formula CaCO3. Find the molar mass of calcium carbonate. Right. Before I solve this problem, I want to go back to this and explain how we can find the molar mass. Now, let's say we're given a formula unit. So, like, let's say we have the molecule, I don't know, H. Let's make it really simple. Hydrogen. This is our let's H2. This is our molecule. And what molar mass is? Molar mass is basically found by the relative atomic mass. Well, not the relative atomic mass, but the relative formula mass. If it's a molecule, it's going to be relative formula mass. So all you do is you add up the relative atomic masses of the atoms that form that molecule, or the element of the ion. You add up the molar mass. You add up the relative atomic masses, and that gives you the molar mass. All you have to do once you found the number is you add the units of molar mass, which is grams per mole. And remember, relative atomic mass and relative formula mass don't have units because they're simply a ratio. Whereas this is actually a quantity which isn't formed by dividing the same unit by the same unit. So it's not simply a ratio. It has its own units. Okay. Relative formula mass plus units, and the units is going to be grams per mole. That's basically what molar mass is. And relative atomic masses, obviously, they can be found from the periodic table, like I'm going to demonstrate here. Now, this is the first problem we've got here. Calcium carbonate has the formula CaCO3. Find the molecular mass of calcium carbonate. Find the molar mass of calcium carbonate. Okay, first thing we do, we have the periodic table here, and we know that we've got 1 mole of calcium atoms, 1 mole of carbon atoms, and 3 moles of oxygen atoms. So what we're going to do here is we get the calcium. We don't need to multiply this by anything since it's just 1 mole of that. We add this to the moles of carbon. That's just going to be 12. And then we add this to 3 times the AR of oxygen, since it's going to be 3 moles of oxygen, plus 3 times 16 16.0, but we can ignore that 0, and that would give us, let me just work this out, 40.1 plus 12 plus 3 times 16, and that gives us 100.1. 100.1. There we go. And this would be the relative atomic mass. So what we've done here is the first stage in a question of this format, which what we've done is we've found not the relative atomic mass, but the relative formula mass, also represented by the symbol mR, just like relative molecular mass as well. Now, what we do now is we simply add units to this, and we know that for molar mass the units are always grams per mole. Usually it's usually going to be grams per mole. So what we do with this is we just put units on there. So therefore the molar mass, or we can represent that by the unit, the symbol for molar mass. Therefore M, big M, which is molar mass, equals 100.1 grams per mole. And that's basically it for that question. Next question, this is the second question we're going to be doing. Nickel 2 hydroxide has the formula NiOH2. Find the molecular mass, find the molar mass of nickel hydroxide. Okay, these are our relative atomic masses here, here, and here, and here. Okay, let's take nickel. Nickel has 1 mole. So what we're going to do here is just add 58.7 to the relative formula mass of this section here, this section. And we know that it's 2 moles of OH. So what I'm going to do is get brackets and basically multiply whatever inside the brackets by 2, and do 16 plus 1 inside the brackets, and that's going to give us, let me see, 58.7 plus 2 multiplied by 16 plus 1 equals 92.7. And as I said before, all we need to do now is add the units to this, because this is the relative formula mass of this whole molecule now. All we need to do now is add the units. So therefore M, molar mass, equals 92.7 grams per mole. And that's basically it. That's basically it for moles. So in summary, molar mass is mass per unit mole. Unity units are grams per mole, and it's equal to relative formula mass. Relative formula mass being represented by the symbol mR. And obviously you can find this on the periodic table. Eventually, we can find relative atomic masses on the periodic table and add them up to find relative formula mass. And, well, oh yeah, plus units, and obviously it's going to be plus these units. And that's basically it. I hope you've got a better idea of molar mass now. Thanks.